Hello everyone, I'm Sebastian Y and this is Managerial Economics. In this video we're going to talk about 4 advanced pricing strategies and directly compare them both to each other and back to the basic monopoly pricing we discussed in the last video. I will be referring back to the numbers that I calculated in that video, so if you haven't watched that yet, make sure you do so. The 4 pricing strategies we are going to get into here are first-degree price discrimination, nonlinear pricing, two-part pricing, and block pricing. We are assuming there are a large number of buyers in this market, each of which have the exact same demand function, given by 24 minus P. Since marginal cost is constant, it doesn't matter how many customers there are, the monopolist can decide on a profit maximizing strategy per customer, and then once we know how many there are, we could just multiply by that. That's the assumption we're going to go with for the rest of this video. Q equals 24 minus P is the demand function for an individual customer. We'll keep that in mind as we go forward. Let's start with first-degree price discrimination. In first-degree price discrimination, the monopolist knows each customer's willingness to pay for each unit exactly. They're able to charge a different price for every unit sold equal to the buyer's willingness to pay. In doing so, the monopolist extracts the entire surplus from the market. For these reasons, it's also called perfect price discrimination. Because of the extreme information requirements, first-degree price discrimination is quite rare in practice. It's generally impossible for a monopolist to know the willingness to pay exactly, but some markets may come close. eBay auctions are potentially quite close to perfect price discrimination because people type their willingness to pay into the computer. Open-air markets, which are relatively rare in the United States but common in other parts of the world, each customer approaches a vendor and they haggle over the price of a good. If the vendor does a good job, they'll be able to negotiate a price as high as that customer is willing to go. Then that consumer walks away and another one walks up. They have no idea what happened with the last one. They have no idea what that person paid, and that haggling process starts again. A used car dealer might do something similar. Let's return to our example where we had a demand function of 24 minus P, and therefore an inverse demand function of 24 minus Q. And we had a marginal cost of 6. We'll draw the graph of this. The demand function has an intercept of 24 and 24 on both, and then we have a horizontal marginal cost curve. And that sits right here at 6. With perfect price discrimination, we can sell each unit sold at a customized price. The customer's preferences reflect the law of demand. The lower the price is, the more they would want to buy. So their willingness to pay for the earlier units is higher than their willingness to pay for the later units. If the monopolist has perfect information about that, they can charge accordingly. Charge them 24 initially, and then as they sell more and more and more, they're going to keep dropping the price down. The monopolist's profit on every transaction will be that willingness to pay go all the way down to the marginal cost. And they're going to keep selling as long as that willingness to pay is above the marginal cost because they can continue increasing their profit. That is not the case with the basic monopoly pricing where we stopped at 9. This also means that with perfect price discrimination, the monopolist is going to keep selling until the socially efficient point is reached. To find that, we're going to plug 6, our marginal cost, into the demand function, and we get a quantity of 18. But since they're charging exactly the willingness to pay for every single unit, consumer surplus is 0, but the monopoly's profit is the entire triangle. Since production continues all the way to the socially efficient quantity of 18, there's also 0 deadweight loss. Essentially, the monopolist is making the economic pie as big as possible, but then they're eating the entire pie. So our monopoly's profit is going to be the entire triangle of base of 18, height of 24 minus 6, that's also 18, and divided by 2. That comes to a total of 162. Compared back with the original monopoly pricing, the monopolist is doubling their profit here, doing much better. Although first-degree price discrimination is the best possible outcome for the monopolist, it's also not necessarily very realistic. Firms can try to approximate first-degree price discrimination with nonlinear pricing. With nonlinear pricing, instead of charging a unique price for every single unit, they charge an initial high price for the first chunk of units, and then drops the price for the subsequent chunk of units if the consumer wants to continue purchasing. Some examples of this include electric utilities and paid parking lots. In parking lots, it's often a higher price per hour for the first few hours, and then after that, the price drops. The simplest nonlinear pricing schemes have just two separate prices, but you can definitely do more. The more prices that you have, then the closer nonlinear pricing gets to perfect price discrimination. You can think of perfect or first-degree price discrimination as nonlinear pricing with an infinite number of prices. To illustrate nonlinear pricing, let's start with drawing the graph. As we found in the previous example, the socially efficient quantity is 18, so I'll just put that in. The idea with nonlinear pricing is we are going to charge a high initial price for the first set of units, and then drop the price down for the next set of units. We're going to charge P1 for the first Q1 units, and we're going to charge P2 for the subsequent Q2 units. This quantity right here is going to be Q1 plus Q2, with this amount of units being Q2 and this amount of units being Q1. Our inverse demand function is P of Q equals 24 minus Q. Our marginal cost is 6. We can plug our Q1 and Q2 into our inverse demand function to figure out the prices for each chunk of units. So P1 is going to be 24 minus Q1 by just plugging Q1 into our demand function to find that point. P2 requires us to subtract Q1 plus Q2. It's tempting to just put Q2 into there, but that's not going to work because once we get to P2, we've already sold Q1 units. And so we need to be right at this point right here. So we need Q1 plus Q2. I'm going to multiply that out to get 24 minus Q1 minus Q2. I'm going to set up a profit function, which is now a function of Q1 and Q2, which will be, as before, total revenue minus total cost. But total revenue is a bit more complex now because we have two different prices and two different quantities. The first Q1 units are sold at P1. We'll use our P1, 24 minus Q1 times Q1, plus our price for our second chunk of units, which is P2, 24 minus Q1 minus Q2, and now we multiply this one by Q2. Not Q1 plus Q2, because we're only selling those Q2 units at the lower price. We now subtract total cost, which is 6 times the total quantity, which is Q1 plus Q2. This is our objective function, and we're going to take our first order conditions and solve for Q1 and Q2. First thing I'm going to do is multiply everything out and collect terms just to clean this up a bit. I'm going to distribute the Q1 to get 24Q1 minus Q1 squared. Then I'll distribute the Q2 in the next part, 24Q2 minus Q1 Q2 minus Q2 squared. And then in the last part, I'm going to distribute the 6 to get 6Q1 minus 6Q2. For this last part, be very careful and remember to multiply everything by -6, and so that negative sign is going to carry all the way through. And now I'm going to collect terms, so 24Q1 minus 6Q1 is 18Q1. 24Q2 minus 6Q2 is 18Q2. And from there we just have minus Q1 squared, minus Q2 squared, and minus Q1 Q2. Multiplying all this out and collecting terms is an optional step, but I think it makes the calculus easier and will make it less likely that you make a mistake. As you can see, this final equation here is a bit less complicated looking than what we started with. To maximize profit, we have two choice variables, so we have two first order conditions. First one, I'm going to take the partial derivative of the profit with respect to Q1, and then I'm going to take the partial derivative with respect to Q2, and then we're going to set both of those equal to 0. Those will be our first order conditions that we're going to use to solve for Q1 and Q2. For the partial with respect to Q1, we get 18 for the first term. For the second term, there's no Q1 in there, so that just drops out. Next, we take the derivative of negative q1 squared. That's going to be negative 2q1. Negative q2 squared has no q1 in it. That drops out. And then finally, we have negative q1, q2. The derivative of that with respect to q1 will just be negative q2. Set that equal to 0. Next, we do the opposite. This is completely symmetric, so this will be very similar to the first FOC. 18 minus 2q2 minus q1 equals 0. Now we have a system of equations with 2 equations and 2 unknowns we're ready to solve. I'm going to take this first equation right here, and I'm going to solve it for q2 by adding q2 to both sides. That's going to give me q2 equals 18 minus 2q1. You could do this in many different orders. This is just what I've chosen to do here. Next, I'm going to substitute the q2 expression that I just solved for into the second equation. So we're going to get 18 minus 2 times 18 minus 2q1. I've substituted that in. Minus q1 equals 0. Multiply this out. Get 18 minus 36 plus 4q1. Again, be really careful to make sure to apply the negative sign to all of the parts. Minus q1 equals 0. Now we'll collect terms. 18 minus 36 is negative 18. 4q1 minus q1 is 3q1. Still equal to 0. I'll add 18 to both sides. q1 equals 6. Next, I'm going to take the q1 that I got and I'm going to plug it in right here. So we get q2 equals 18 minus 2 times 6. 18 minus 12 is also going to be 6. The last step is to plug these quantities that we got into our price equations that we started out with. So I'll rewrite those. We had P1 equals 24 minus Q1. We had P2 equals 24 minus Q1 minus Q2. And so what we get is P1 is 24 minus 6 is 18. P2 is 24 minus 6 minus 6, which is 12. Let's finish this up by calculating the profit that we make here. We're selling the first 6 units at a price of 18, so 18 times 6, and the second set of units at a price of 12. We're producing a total of 6 plus 6, or 12 units, and each of those cost 6. This comes out to a total of 108. Comparing this back with perfect price discrimination, we had a total of 18 units, so we're producing less than that, but we're producing more units than the 9 than we would have with just the single price monopoly. The profit that we make here is also in between those. 81 for basic monopoly pricing and 162 for perfect price discrimination. Nonlinear pricing is in effect a midpoint between single monopoly price and perfect price discrimination. If we were to try this whole problem again with 3 prices instead of 2 prices, we would produce a little bit more and we would get a little bit more profit. The math would be more complicated, but we could still do it. We could continue adding prices, and the more prices we add, the closer and closer we get to first-degree price discrimination. Let's go back to the graph and put in everything that we just found. The first 6 units are being sold at a price of 18. The next 6 units, so we're going to get to 12 there, are sold at a price of 12. We're going to make a profit of this box right here for the first 6 units, and then we're going to make an additional profit of this box right here for our next 6 units. And so what we get is this stair-step shape for the profit. The consumer surplus is going to be this triangle up here for the first 6 units, but then it's going to be this triangle right here for the second 6 units. So here consumer surplus is the sum of these 2 small triangles. This has gone down from the basic monopoly pricing, but it still does exist. It doesn't go to 0 like in perfect price discrimination. Deadweight loss is down to this triangle right here. That is smaller than it was with the basic monopoly pricing because we are producing a higher amount of output of 12 as opposed to 9 that we were before. Consumer surplus is 2 different triangles which have a base of 6 and a height of 6, and there's going to be 2 of those. So that's going to come out to 36. And our deadweight loss has a base of 6, a height of 6, divided by 2, we'll get 18. Now, if you imagine what this would look like with more than 2 prices, we would now get 3 stair steps. Consumer surplus would be 3 even smaller triangles. Deadweight loss would get a little bit smaller. If we added 4, we would get 4 stair steps, 4 little consumer surplus triangles, an even smaller deadweight loss, and so on. The next strategy we are going to look at is called two-part pricing. In two-part pricing, consumers are charged a fixed fee for the right to purchase, but also get charged a per unit price for each unit that they purchase. Once they pay the fixed fee, then they are allowed to purchase as many units as they want for the per unit price. The per unit price is lower than the normal monopoly price, and to maximize profit, the monopolist actually drops their price all the way down to marginal cost. That means they make no profit on each unit they sell, but they're going to make that up in the fixed fee. One of the best examples of this would be warehouse club stores like Sam's Club and Costco, but health clubs and golf courses also do the same thing. As with our example on nonlinear pricing, I'm going to start with the graph. In two-part pricing, we are going to drop the price all the way down to marginal cost, but then make up the profit in the fixed fee. If the price is equal to marginal cost, in our example, it is 6. The demand function we have is Q of P equals 24 minus P. So if we just plug that in, we get Q equals 24 minus 6, which is 18. That is our socially efficient quantity. So just like first-degree price discrimination, two-part pricing is going to result in 0 deadweight loss because the socially efficient quantity is being produced. If we drop the price all the way down to 6, the monopolist makes 0 profit on every unit. And that would make this entire triangle the consumer surplus. That consumer surplus would be a base of 18, a height of 24 minus 6, also 18, divided by 2, which is 162. So our consumer would enjoy this low price and get a large consumer surplus of 162. But with two-part pricing, this is not where we stop. We are going to charge the consumer a fixed fee in order to access this low price. How much would the consumer be willing to pay? They would be willing to pay up to 162 with their consumer surplus to buy into this deal. And so I'm going to set F equal to 162. Now the consumer's consumer surplus will be the 162 that they get from all those transactions minus the fixed fee of 162, and they would get 0. This makes them indifferent between buying in and not buying in, and so if we wanted to be really careful about this, we could make the fixed fee slightly under 162 to make sure that they do it. But I'm going to call it close enough to 162. This then converts this consumer surplus entirely into profit. To formally calculate the profit, we have a revenue of 6 per unit times 18 units, plus the fixed fee of 162, and the total cost is 6 per unit, and we're producing 18. So of course these two cancel each other out, and we get a profit of 162, which is just the fixed fee. So again, with two-part pricing, we make 0 profit on each unit, but make that up in the fixed fee, and in doing so, make the same profit that we get in the very difficult to pull off first-degree price discrimination. Two-part pricing did not require us to have perfect information and unique prices for every infinitesimally small unit in the market. We just needed to charge a fixed fee of 162 and let the consumers buy at the low price. The final strategy we're going to look at is block pricing. In block pricing, multiple units of identical products are packaged together. Consumers are not allowed to buy individual units, which forces consumers to make an all-or-nothing decision to purchase. An example of this would be 6 packs of beer. You generally can't buy a single bottle. Pencils, which come in a large package, and toilet paper, which also generally is not sold by the single roll. Let's return to our example. From our previous example on two-part pricing, we know that the efficient quantity to sell is 18, and that represents the highest potential for profit. If we sell this good in packages of 18, then the consumer is forced to make this all or nothing decision instead of making a marginal decision like they normally would. The consumer's value for all of these goods is going to be the area under the demand curve up to 18. And so that is this whole area here, which is going to be a trapezoid shape. To calculate the area of a trapezoid, we take the average of the two unequal sides here. One of them has a height of 6, the other has a height of 24. We take the average of that, so we divide by 2, and then multiply by the base, which is 18. That gives us 270. 270 is the total value the consumer gets from consuming 18 units. And so that would be their maximum willingness to pay for that package of 18. Just like with two-part pricing, we're going to set the block price equal to that willingness to pay. Or again, if you want to be really careful about it, 270 minus some tiny amount. Again, I'm just going to call it close enough. The profit we're going to get is revenue of 270 minus the cost to produce 18 units. 6 times 18, which comes out to 162. The exact same profit that we made with two-part pricing and with first-degree price discrimination. The way that we can see this on the graph is that the total cost for the monopolist was this area, 6 times 18, and so we're left with a profit of that exact same triangle that we had before. We again have a socially efficient quantity of 18, the highest possible profit for the monopolist of 162. This mimics the effect of first-degree price discrimination, but again, without the extreme information requirement. On the screen, we have a comparison of all of the numbers that I calculated throughout this video and the last video. This gives us a comparison of all 5 of the different pricing strategies that we looked at, from the basic monopoly pricing on down the list. In reality, which strategy is best depends on the specifics of the situation. It's important to remember we are just looking at some economic models which present a simplified view of reality. Real life is never quite that nice and clean. The nature of the market and the good being sold matter. For example, if a good cannot be effectively stored, block pricing does not make sense. A firm should also consider how much administrative overhead they're willing to take on. A two-part pricing scheme requires keeping track of memberships, who paid the fixed fee. It's also important that consumers understand the pricing scheme, which can be a problem for complex nonlinear pricing schemes. The more prices that you have, the more confusing it is to customers. In the next video, we're going to look at 2 more examples of advanced pricing strategies, versioning and bundling.